Thank you, Divya ma'am, for this warm welcome. I'm glad to be a part of this program. So I think we can start now.
Yeah,
So I'll share my screen.
yeah, sure.
Let me know once my screen is visible.
Perfect.
Yeah. Uh, so today our session will be most of all on this computer vision and image processing thing. Uh, have we will at the end of this session we will doing few hands-on projects on computer vision, and so about me, I'm an as Divya ma'am has introduced me, so I'll take myself for a few minutes to introduce myself also. So I'm Nayak. So I'm a consultant at LTTS, L&T and Technology Services. I have 4 years of experience in deep learning and computer vision. So, and one more thing, I'm looking for this session as to be an interactive session. So if anybody have any queries or anything in between, so you can just raise your hand, or you can directly come up with your problems, like any query or anything if you don't understand. So agenda of this session will be mostly on computer vision and what types of uh, what are the types of computer vision, or what type of problem we are dealing with, and what will be the applications, and how we should system should be designed on computer vision, how projects should be deployed, and at the end I'll be demonstrating few projects, so how we can do projects on this computer vision. So, computer vision. It's a field of artificial intelligence that enables computer and system to derive meaningful information from digital images, videos, and other visual input. So, and taking actions on it and making a recommendation based on this information. If AI enables computer to think, computer vision enables the computer to see, observe, and understand. So all this computer vision, uh, the computer vision is like it has few parts on it. So basically computer vision deals with image, deals with the information which we get from camera, through digital images, videos, or any other visual input what we get, and we process it, and we give a alert, or event is occurred, and that event is fetched to the machine so that they can react on it. So it's like a small brain to a computer to understand the environment. So if we want to start with this computer vision, it has to be start with neural network. So let me first get into this. So deep learning is the first stepping stone towards this computer vision. There are deep learning is it's just like mimicking a human brain, how human brain understand things, networks, the synapses and everything. It's the same replica of it which we uses in deep learning. Deep learning are the collections of neurons in a structured format, and that structures are actually prepared by the developers as per the trial and error, or like understanding the business use case. So that it mostly people say it as a black box, but you can, like a developer can just open up that like it can prepare a black box, a structure of a black box, not the whole. If you want to identify an image, so if you want to do anything on a deep learning, so first change we need to convert our problem statement into numbers. Generally, to solve any problems into deep learning, one should know how to convert the problems into numbers. Once your problem is converted into your numbers, then that numbers are fetched to the neural net, and neural net will give an output. So if that output is not to the actual value, that predicted output, then it will again fetch to the neural network. So I'm saying about all this because before diving into this hands-on computer vision projects, one should first understand what deep learning is and how this all procedures are working on. So once, if everyone understand what deep learning is, then I'll come up with the CNN. Actually, this deep learning is again having a few structure, a few constitutes into it. It's like there are few different types of neural network, like uh, CNN, RNN, ANN. So according to our use case, we deal with a particular kind of structure of deep neural network. So if we are dealing with computer vision, so our main major focus will be on the CNN side. CNN are the uh, yeah, this whole structure which you can see here, this one is actually a CNN structure. So before diving into any of this computer vision project, one should first understand what CNN is. So it is so this red structure, not red, this whole structure from here to here, it's all of a neural network. And if we are giving an image input of 0, it should at the end of the uh, whole process, it should predict 0 here. So through the image, it has understand like this structure of pixels which are present, and this we don't directly give a image. Actually, this image is then converted into a number format, and once that number is fetched to this network, it will understand how to predict a 0. So not 0, like any images. So let's just come to a computer vision now, because I understand you right now, you understood what deep learning is, and then under the hood of it, what CNN is. Then computer vision, like we can, any problem statement which is in computer vision can be solved using image processing or deep learning. So when we come up to a image processing, so the famous tools are MATLAB or OpenCV package Python. So through that we can do edge detection or contour detection. And when we say image processing is highly confined to the light of light present in the environment. So if it is it's not trainable, it is quietly dependent on many parameters like light, pixels, and most of the things. And when we come to the deep learning is, we can say, it is highly independent of the environment. It's mostly depend on what kind of data we are giving to the neural network, and how much we are training it. It's all of like when a small child is given a red ball, and we have uh, mm, once, let's just consider, we have given a small baby a ball, and we took it with him, and we asked like color of what was the color of it, he won't be able to. So when we explain it, this is a red color ball, and again when we give that ball, then he will understand it. So deep learning work in that fashion, whereas image processing is most of hard coded, like we code according to the light exposure and everything. So with this image processing, we can do edge detection or contour detection. It's like within a frame of an image, if like a similar pixels will contourize to a single thing, it will detect in that way. Whereas in deep learning, it's all about like what kind of data we are giving. So if we are giving a data of a ball, and how diverse variety of ball we are giving to detect a particular neural net, it's depend on that. So under the hood of this deep learning, there also comes a transfer learning. It's a it's like when we are working on this deep learning, we it like every time training a model could be a tedious task, and training a model takes a huge time. It's still it's depend on the uh, data, how much data we are giving and for how many iterations we are training. It's depend on that. But then to training a model, it quite hectic and it is computationally high. It is time complexity wise also it's very high. So so basically what we do is, if we are working on a similar kind of mm, problem, then we can use the pre-trained model which we have used before. So reusing the weights and layers, uh, we can do that. So like right now, let's just consider we have created a deep learning neural net to detect a red ball. Then that same structures can be used by modifying the final layer, and we can detect another ball also, or another thing also, classify other things also. So, basic structures of computer vision. Image class, there are three structures. Like it is broadly classified into three class. It is most classical problem of computer vision. Either we do image classification, we do object detection, or we do image segmentation. So the as problem stated, there will be a classification, object detection, and image segmentation. In image classification, we basically classify a image of what, uh, like within a image what it is, if it is a cat or a dog. So it won't be giving you at what location it is, or where it is, or how it is. It will just classify. So let's just consider here is a cat. So cat, right? So it will just throughout the image, it will just classify if this image is a image of a cat. And then there is another problem statement where another this structure of it, where it is object detection. Object detection is the what we say, it is the addition of it with image classification with localization, is known as object detection, where we don't even we not just classify a image, we also detect at what location that image is, with a bounding box, or like we can without bounding box also, like we can detect, we can at the end output we will get at what location it is. So there lies one more problem statement where we deal with the image segmentation. Since this object detection is giving us a bounding box to the whole image or whole object, but in image segmentation it is pixelate wise. To the whole pixel it will detect. So throughout the pixel it will create a layout, edge layout of the object. So image segmentation is a method in which digital image is broken down into various subgroup, like a cluster of pixels into a one object. So image segmentation, computationally wise, image segmentation is quite high. Image classification, when we come to the image classification in practical use case, we don't find much application on image classification, but there are applications of it. But as per my experience, I found out image objectation is having a wide application in it, and it has its own peculiarities. So with the location, we can use it on robotics, or we can use it on various other places where we need to define a location. So you might be saying why we are not using image segmentation, because it's a pixelate wise differentiating the object. But training the algorithm into this image segmentation, or during this computer vision mm, preparations, we do the annotation of the image. Annotation, it means, so through the within the image we give a labeling of it, okay, like this is dog, or this is cat. So while this labeling, annotating this segmentation model is quite high, because we need to uh, do each and every pixel, to the each and every pixels we need to draw it. So it get very tedious. And it's not that like in practical wise it's not that feasible to do image segmentations, but in industry people are doing it, but at a very low level. So as the industry problem is concerned, we mostly use object detection because it gives a localization with classification, so it plays a very vital role in computer vision. Let's just focus more on this computer object detection problem statement. So in object detection, we basically, when we do the whole inferencing, after inferencing is what, like the we get the output that is known as inferencing. So in the inferencing we basically get the confidence score of the object. So within a frame, I'll at the end of the, while demonstrating the project, I'll explain you even more. So mm, at the final output we get the confidence score and we get the bounding box. Confidence score is actually the score of the confidence of the object. So what is the confidence of the object, so what model is detected, and bounding boxes size, the localization of the bounding box will also be stated. So object detection is giving these two things, and the popular algorithms for object detections are, it started with RCNN, faster RCNN, and there is a YOLO family which is working, which is which is working exceptionally best when we work on the real-time project, and SSD mobile net, SSD object detection. So if we want to deal, if our it's the selection of these algorithms are widely depend on what kind of problems we are dealing with, how severe our problem is, or how speed we need the output. So but everyone requires the high speed as well as high accuracy, but all algorithms doesn't come under the one bucket. So YOLO algorithm is right now it's in a way, like it's developing, the researchers are working mostly on this YOLO family. So in YOLO, we, when if we want to differentiate between this YOLO and SSD, both are single shot object detection, which is the scope of this session. But YOLO is itself, if you want a high speed object detection, then one must select this YOLO. And if we need a very high accuracy, then faster RCN SSDs are great to work on. And YOLO families, we cannot suppress the qualities of this YOLO family because it's every day new algorithms or new update has been coming. So recently YOLO V6 has arrived, and then YOLO V7 also arrived. So it's in a very developing stage. So you're working with YOLO is also fascinating. Let's just comes to the applications of computer vision, where we can apply the skills of this computer vision into the everyday problems. So it's used almost, I can say, in, we can use computer vision in every domain we can. So when we these are very less problem statement which I have uh, pinned out here, but there are ample more amount of problem statement which are around. So there is, for geological analysis we use it. There are autonomous vehicles, warehouse, most of the uh, this computer vision deployment you might have seen in your day-to-day life in CCTV cameras, or in temples also you will be able to see this, where if a person, or in shopping malls, whether a person is wearing mask or not. So there are ample amount of real time problems which computer vision is dealing with nowadays. So geological analysis, in geological analysis we are using it so to recognize a pattern. So the images captured from the satellite can be inferenced out here, inferenced with uh, in we can get the output of it, but detecting a particular object from the geological point of view can also be used in computer vision. And then In autonomous vehicles, we are you might be knowing this Tesla, which is a prime example of autonomous vehicles. They do 3D mapping, tracking of cars, lane detection, and everything. uh, I'll try to open this link to showcase what it is. So there is also a warehouse automation. In warehouse automation, we are using so to detect boxes over under the warehouse, detect exact boxes using OCR extraction. So in all the boxes, there is given a carton number or the mm, or the invoice of it. So uh, extracting the data from the invoices can also be used. And in warehouse, detecting particular object or detecting the flawless in the boxes can also be find out through this computer vision using a camera. In precision manufacturing, solve complex precision manufacturing is like PCB industry, P, mm, printed printed circuit board. There also detecting a fine line or any faults in PCB can also be fetched through this computer vision. Damage assessment, that is visual inspection of your vehicles, visual inspection of your sometimes in mobile phones also they are using computer vision. Right now in sport analytics also computer vision is being used heavily. So analytics of a person or of a player, we are using computer vision. Analytics of the audience, how interested audience are, we are using computer vision. So computer vision is widely applied in many domain. These are very less domain which I have stated here. So so let's just come to this computer vision pipeline. If anybody wants to create a uh, computer vision project, so whole end to end, then one must has to come up with this, one must have to come down through this pipeline to create a computer vision project, to deploy it and use it in day to day life. So framing a problem, the first step is framing a problem. And while framing a problem, one should carefully understand what the end goal should be, and he has to be keep that in the point. Because in computer vision is a very hybrid domain where we switch to other platforms. So understanding what your problem statement is should be the first thing, and it should given a good time to understand what end goal would be. Once the end goal is fixed, then we can come up to this data collection. So and when I say end goal, so if you want to deploy your computer vision or your machine, your object detection model, so where we want to deploy, or what will be the load on it, what kind of uh, people will be there on the platform, and what will be the size of the model, and everything has to be keep in mind before getting diving into the pipeline. According to that, we have to decide what platform we should choose for at the final stage. So once that problem statement uh, is fixed, then we can come up to this data collections. uh, from where we are collecting a data, how hybrid it is, the data is collected. When I say data in computer vision, that mostly depend on the image, what kind of images we are taking, how variety of images we are taking, and uh, how at what lighting conditions we are taking. Because if we compare our model with like let's just consider we have took all the images of a daylight, and we have tried detecting a model on night, then it won't be able to detect. So it will be a big failure. So while collecting a data, it should be very diverse, and it should be very diverse. That should be the one thing. And from where we are taking the data and how we are taking a data, That should be the prime agenda. Once data is collected, what is the size of the data has to be noted. So according to that, we need to do a annotation on the data. So if the data sizes are very high, so if we annotating that amount of image could be a very tedious task. So annotation itself, annotation means it is a process where a human give input to an image, uh, about like it's computer vision, its whole itself is like a human is giving his intelligence to a machine. So when we say this, then while annotating an image, it's like within an image, if we are detecting all the persons present in an image, then what human is understanding and what bounding box it is creating on the image is that what computer your model will understand. So annotating should be accurate. And annotating is that process is known as annotation, is like throughout the own image, we will create bounding boxes on the image. So that procedure is known as annotation. And this annotation, once this annotation process is completed of all the image, mostly in computer vision, the images size is of high, it varies from problem to problem. Sometime it is 1000 to, when Google train its model, they decided to take more in millions of data. So annotating those kind of data is very tedious. So that's a huge time consuming, uh, within the pipeline, that is a huge time consuming time. So then we comes to the, once the annotation is done, we are giving this annotated images to the model deployment for benchmarking. We uh, we we don't directly deploy this model. We take this annotation model and we train the model as per our requirement. And with the, like, once the model is trained, which model we are choosing, or how, what accuracy we are deciding, that is the main factor. And once that is like the model is being trained, so then we can move forward with the deployment. So this training procedure is also, it's like it's a whole and soul depend on where we are training. And this pipeline is a quite time consuming pipeline. So when training your model, it's, if you are training it on cloud, it takes time, it take bit less time. But when we are for training a normal model into our system, it requires a GPU. So with the CPU, we also need a GPU to run our model. So that is also a huge case, one should look on. So if we don't have a GPU to run, then we can use cloud services like AWS. There are various other platforms which are providing GPU to train our model, so that everyone who are interested in computer vision can work on this system. So training a model into cloud, when we say cloud services, then there are, for of Google there is a GCP, from Amazon there is AWS, then from yeah, Azure there is there. Then Paperspace is also a platform where we can train our model. There is a collab model where we can train a model. So there are different things, where Google is also providing free GPU to try and inference the model. And it's a continuous procedure. Once a model is deployed, we check its accuracy on the real time image, the test data. And once it's not able to detect, or the accuracy is not that high, then we again give our model for annotation. And then once the annotate, then again we give few images to annotate. And once object is annotated, then again we give it to model training. These two procedures are like continuously happening. So it's depend on uh, when we uh, reach our satisfaction value of accuracy, or the speed, not speed, accuracy and confidence value. So then once it is reached to our our satisfactory value, then we give it to the deployment. And when the project comes into the deployment phases, there are various there lies two problem. One, either we can deploy it on edge devices. Various edge devices are present where we can deploy it, or we can deploy it on cloud. When we say edge devices, the edge devices there are wide variety of edge devices right now, like Raspberry Pi, from Nvidia. There is Nvidia Jetson, Nano, Xavier, and there are many others where we can deploy our model. Or if we want to deploy it on cloud, then there are paid services present out there which one should look for. So this is whole end-to-end pipeline to come from starting to end of how we can create end-to-end computer vision model or computer vision project. So there lies one more out of this three. There is one more structure of computer vision where we deal with this GAN. GAN is the exceptional, we can say, it is the exceptional part of computer vision, which is highly uh, emerging right now. So it is, GAN is actually it's like how the images are, how we can replicate an image or create a unique image. It's a, we can say it is a generative model. Generative models are those models which generate a data set. Right now, since so, uh, we have a data, so if we need any unique data regarding to the same thing, so if we give our mod this GAN a few 10 or 20 pens, then it has that capability to create more 5 to 10 different unique pens, taking the data set from this 10 to 20 pens. So it has that capability. So this is the whole, this is quite a, it's a small structure which will be helpful to understand GAN, what GAN is. So they enable the generation of fairly realistic and synthetic image, of forcing the generated image to statistically almost distinguishable from real ones. It, you cannot distinguish it, it is a fake or a real one thing. And it's within a model there is a generator network and there is a discriminator network. One network will generate a model, and that model will be fetched to this discriminator network, and this that discriminator network will discriminate whether it is real or fake. And if that descriptive network introduce it as a real, then that gives the output. Okay, like it is a very unique, it will create a very unique object out of it. On the later demonstration I will showcase how it happens. So the process of training GAN is quite tedious, and it is quite difficult. People say it's difficult because it has highly variety of parameters which has to be keep into consideration, because since we need to create an image which human has to, which we need to fake it to a human itself. So if two images are given, the third image should be synthetically, which will be synthetically prepared, but human will not be able to understand like this is a real or a fake. It has to be that accurate. So creating that accurate object has to go through a very notorious task or notorious parameters which has to be varied over. GAN is a very emerging field right now, and it has a wide applications on media industry and various other industries. So let's just focus a bit on this project deployment part, because that's what people usually neglect it out. People create a model but deploying is also a tedious task which one should look on. So deploying your model should be as I stated below before, it has two phases. One, either we can deploy it on cloud, and once it is on cloud, we can inference it from anywhere. And one good example of this deploying on cloud is the lens card. If you have gone it through the lens card application, it has that thing. You can directly try take a frame, and that frame will come up to your face, and uh, you can directly check. So that is one of the deployment which is which is given on deployed on cloud. So when we say deployment on edge, then there are wide variety of microcontrollers where we can deploy it. And deploying this computer vision model into cloud is deploying this model into cloud. So it's highly depend on what is the size of the model, what will be the how the what will be the size of the input will be given to a model. Regarding to that, we decide what kind of models we will do. So we will take. So there is NVIDIA Jetson series, which are widely used in this project deployment. So when I say Jetson series, there is Jetson Nano, there is Jetson AGX, Jetson mm, Xavier NX, AX, and recently they have introduced Orion, Jetson Orion. So if your model is quite high, I would suggest one should use Jetson series or this Google Coral series. This Google Coral series is also not that uh, computationally that not much that high, but one can be able to deploy their model on Google Coral for a demo project or for a demo. Second, then third, if your model is a bit low, or one wants to introduce it to the variables, or one want to introduce it mm, uh, to a very if your model is very small and it is detecting just one object, and they don't want to scale it to a more further, then one can use Raspberry Pi 3 or 4. Then from Arduino also there are few microcontrollers, very small microcontrollers which can be used. There is ESP32 CAM where we can deploy this. This might not cost much. This section might not cost much, but one will be able to inference their model, and inferencing a model in a small footprint edge devices can be very beneficial and will be cost effective, and one can introduce easily to the customer or to the real world. Since it is computationally, it will be low power, but it will be able to detect the object, or it will be able to you will be able to detect your model. But your model has to be, after this whole pipeline which I have stated before, that pipeline has to be again has to be uh, modified, bit modified, and then we can use it on low computationally edge devices. So the projects are right. This is one of the project which I deal with. So when I say geological analysis, so this is one of the example of geological analysis. Is like through the satellite. This is the satellite view, and through the satellite view, it as per the Google Map, it is expected to be Google Map is expected to give this output. So I have trained this model and I have got the output of this. So with this, it gets very easy to define or to define the places. So we are using computer vision on this platform. So for this, we are using this GAN to generate this kind of model. So we have given this source and we have given expected, like we need to give a thousand or lakhs of images through the model, and then it will be able to detect, it will be able to generate this kind of image if a new input is given. So let's just consider this is a new input which is given, which is being trained this kind of thousand of images, then it is able to detect create this kind of images. So you might be saying, this is not much accurate, but if you want to, if we train it even more, then we can achieve this kind of accuracy. So technically I have just trained it on a very sophisticated platform on my only system, not on a cloud GPU or something like that. So if we train it on a cloud or at a very high computational GPU, then we can be able to train the model. We can achieve this. So this is also one of the GAN mm, use of GAN, where where we can restore the old image into highly HD images, like high definition images. It is using GFP GAN. GFP GAN is one type of a GAN where where we have added a certain layer, a channel split spatial feature. It is a kind of a feature layer which is being placed in between the model, which has been able to create this kind of output, this kind of uh, cleared image restoration, cleared output. So we will come up to this later. And uh, so let's just dive into hands-on project. So how we can I will demonstrate few projects, or 2 to 3 projects. So before to that, Divya ma'am, are you, can we take a 2 minute of break for that?
Yeah, sure, sir. No issues.
Yeah, uh, I think we can start.
And anyways, like I mean, I'll unmute every participant so that it's
Yeah,
going to
before
be a
to
bit
that,
interactive.
yes, before to that, yeah, if you have any
Yeah.
queries, anyone, so just come up with that.
Okay. Like participants, like you're all unmuted. So, like from the theory
Okay.
part, if you have any queries, you can please ask before we move on to the projects demo.
The cloud resources are there for training our model. Except other than Google Colab, is there any other resources, sir?
Other than Google Colab,
Yes, sir. Like there are
yeah.
some limitations, like above 5 hours, the model is getting crashed.
Okay. So to let me just first clear it about the Google Colab. So in Google Colab, if you are using a trial service, then Google Colab will be disconnected you from 1 hour to 12 hours anytime. So your model will get crashed. One thing. Second thing, if you want to use your model into cloud, then you can use a free service of it, not for a paid service of it, which will be costing you around 750 or 800 rupees. It's around $10. So with that $10, so you will be able to train your model, and it won't disconnect uh, till 12 hours, and you will get a good storage amount also. Other than Google Colab, so this is all about the Google Colab. Other than Google Colab,
Okay.
there is a platform called Paperspace that is able to give you it is bit cost effective, but you won't be able to connect much data. You won't be able to connect your, so, drive into that, and you will be facing bit problem. So that's why people mostly use Google Colab. Other than Google Colab, I would suggest there is a Paperspace. There is also other cloud services are also giving, like this uh, Azure and AWS for the training, but those are paid.
Okay, sir. Okay, sir. Thank you, sir.
Uh, any other queries from participants before we move on to the demo? Okay, I think Animesh, we can proceed with the demo part.
Yeah, okay. So while demo also, if anybody have some queries, then they can directly unmute them. If they has that ability to unmute, then they can just
Yeah, right
otherwise they
now
can
I've
message them.
given
Yeah.
that permission, so they can
Okay.
unmute and ask.
Okay, fine. Okay. So I'll share my screen. Let me know once my screen is visible.
Yeah, your screen is visible.
Okay. So first I'm demonstrating the PCB fault detection project. It will detect whether all the components present in the uh, mm, PCB has to be detected, and if the components are not present, then it should mm, give a alert, or it should define like which components are not present. So before to that, let me first start the environment. So here we have used YOLO V5. It is one of the object detection model which we use, and we have also used a web-based UI, which is able to we are able to create a UI in it, and through the UI it's like a kind of a control center for a PCB manufacturer, where through the here there is a drop down where we can decide what kind of PCB do we have. Either it is from the manufacturing unit or it is from the service unit. So let's just take it as a manufacturing unit now. So what kind of data we want to give. So right now I don't have the PCB of it right now, so we are not displaying on a on a webcam, but I am having an image of it. So here we can select either you are using it for camera or video or image. So I'm taking image, and then so here is the, yeah, either I can drag my image here, or I can, using browse file, I can browse. Okay. So once I've given my image, it will go to this network, and here it is showing the image is uploaded, and here it is showing status of the PCB is not defected. Since we have given this model, like there are all these components which has to be present. So once all the component is detected under this PCB, it will give see present component. If I don't know whether it is visible or not, but whether present components, all these components are present. Since there is no component which is missing out, then it's showing absent PCB. In absent PCB, it's showing all components are present. Secondly, here the status is not defective. So this is the whole demo in this whole project. So how we have deal with it is, yeah, I have stopped it right now. That UI won't work. So here this file is where we have used the UI of one very famous package of Streamlit, where this st stream, here I have defined Streamlit as st. So Streamlit has given that functionality to create a sidebar. So okay, it has gone. So since I have ended the session, so here control center and everything. At the end, we we have asked our model, so result.image, here it is given, it will give the output at this point. So before to that, so the model which is detecting this thing is here. We have used YOLO V5S model. It's in a PT format. So various model gives the output in a various other format. Like we have for image, we have JPG. For video, we have MP4. So here we are using the YOLO V5 gives a PT format of it, .pt format. Since and always in the object detection, the image size has to be given before itself. So the size we have choose is 640, is as per the neural network. So these are the parameters. These are the parameters which we are dealing with. So weights are actually the model file which is generated. Source is from the image, from the location from where we are taking the source, the image. Size of the image is 640. Then threshold, confidence threshold, the model, the object which is being detected, that confidence, at what confidence it should give the output. If you give their 100% confidence, then unless and until model is sure with the object, whether it is uh, whether it is 100%, when the model is 100% sure, then only it will create a bounding box out of it. So at normally we usually give 60 to 75% of accuracy to understand the model, to model to understand the object. IOU is the uh, interest, it's on the union. So like what confidence the out of the bounding boxes, there are different, there are it's a bit technical term. So it has to be uh, maximum detection. So within a detection it will maximum it will detect 1,000, since our model has to be detect not more than 10 to 20 detections, because uh, within a PCB there won't be more than 10 20 objects. So device is like whether I'm using GPU or not. So since it's my computer don't have GPU, so I'm not using GPU, and all these parameters are all depend on the models. And here I have like given a command, it's all on Python. So I have given a command over which one to classify or video path. It's return, it's on OpenCV. So through the OpenCV I'm using few parameters from there. So and if the device type, all these parameters are give the, for the parameters the methods here the all complexity, computationally complexity is given here, which model has to be choose. If webcam is asked, then webcam should be shown, or if not, then it should directly go to the source and it should detect the image and it should give out. So if we have given a CPU, then what should do. So if and else statement has to be given at every phases. So through it kind of a try and catch error. So because it should not be crash at any time when the system is running. So we can also have, we are also having that ability to save the image of detected object, so that we can have a log file generated of it. Okay, like if throughout the stands 100 PCB go through the conveyor belt, and it has to be create a log file of it. Okay, first PCB was having all this component, second PCB was having all this component, and if in the fifth or sixth component, PCB, if one of the component is missing, then it has to be tracked down. So all this functionality has given in this. Uh, so we have trained so this model file you can directly take it through the real author of YOLO V5, and you can try molding it, and you can achieve this kind of uh, project. So with this demonstration, if anyone is having any queries, hello, am I audible?
Yes,
Hello.
sir, audible.
Yeah, okay, okay. If interaction won't be there, then I won't be able to understand what you guys understood with this. Anyone interested in computer vision?
Yes, sir. Yes, sir.
Any queries? Because I haven't explained it in a whole and everything. So you might be having any queries on this. I have genuinely not shown everything. I want you to come up with the problem so that I can explain you. Is there anything? Or I should go with the other? So I'll demonstrate one more.
Animesh, I'm sorry. This is
Yeah.
why I actually muted. I actually muted the participant now.
Okay, okay, okay. So if anybody will be having query, then they can, if they can raise their this thing, or what it.
Yeah, I think that would be better. So can I mute all participants again?
Yeah, yeah.
Yeah, like participants, please raise your hands if you have any queries. And if you want to give a thumbs up, then please use the reactions so that the speaker will know. Yeah, you can proceed, Animesh.
Okay, okay. So here I have deactivated the actual environment which I have created for that project, and one should always follow this environment procedure. If you are creating a project, one should always create an environment for that particular project. It will be for storage, it may be a bit high, but it will be good at a long run when you are creating more and more projects. So yeah, let's just come up with this. So I'll first explain what problem statement is this dealing with. So here, if it's like a CCTV, so if a person is detected within a frame, it will directly give you the out. It will directly intimate you on your Telegram, on your phone application, Telegram application on your phone, and will give you the image of that particular person who has entered the room under the camera. If he comes, then it will get intimated. Mm, so if a person is detected, that person is detected within a frame. And if I'll show my camera, yeah, so if you can see here in a Telegram, I got this notification that person is detected, and here that image is also arrived. So unless and until I'll move from here, it will still work. So again I have entered the room, so it will alert me, as well as that image has come to my Telegram right now again. So I'll explain how this code runs. Here I have used this package, this pre-built package, which will detect a human present in the frame. And once that person is detected using video capture, it is for the video capture is for the frame. And once that frame is opened, so it will come under this, the pose detector. So pose detector is actually a detector which will detect a person present. And then sound, here I have used a package called pyglade for sound. So once a person is detected within a frame, then that frame will be uh, then the sound will alert, will give a alert of it. And people, I have given a first, it will be false, then it will change. So it's like a predefined, I've given it. So path is, this is the path where image has to be stored. So image will store also in your local machine, and also that image will send, that image will be given to your Telegram application. So this is the, for the, so how I have connected my Telegram to my code is actually the main thing. So URL HTT, this Telegram bot, I have created a bot, and through the googling you will get to know the how to create a bot. And once that bot is created in your Telegram, you will get a token number and chat ID. It is, if you use this chat ID and token number, then that image will become to me, not to you. So I'll recommend not to use this token ID or chat ID or this ID. And caption is like person detected, so what message you want in your Telegram to come, so it's the same thing. And here is the very basic code of how video frame should be opened in your system. And if your video frame is open, then that like video frame is actually a kind of ample amount of images which is being processed at a particular fps. So once within a frame, if a person is detected, then this block is for uh, mm, uh, the rectangle, the bounding box, and CV2 the put text. It like once the object is detected, then it should, if the object is detected, then people detection should be written in at the top. So that is given. So at after 30 seconds it should check key whether if anyone comes under the frame or not. So that so here this line is CV2 dot write is used for saving that particular image where person is detected into your local machine. And then rest request is a request we have given to the token ID, which is a Telegram. So this is for sending that image to your local to your Telegram. So it is very simple code through which we can create the this CCTV person detect CCTV camera kind of thing. And if right now it's working on the system, so how we can scale it is like what kind of edge device we can use this. So we have to look onto that part. So once that, so if we have used the edge device of costing around 2000 or 2500, then we can create a whole CCTV under the 2000 or 3000, which will detect a person, and it will be personalized and given that particular image will be given to your Telegram, to your personal Telegram account. And it will be nice to explore. And this is one of my interesting project which I have done. So if anyone is having any queries on it, so please. I think someone has
Yeah,
raised.
yes, sir, yes, sir. Part Desai, you can please unmute and ask the query.
Hey, hi, Parth here.
Okay.
So, anyways, it is possible instead of the message via calling, because sometimes the message it is not a good choice, right? Uh,
Okay.
because if we are in a work and some busy, so at that time call is the good option instead of
Okay.
the message. So
So
it is possible.
instead of message in your Telegram, you need a calling in your Telegram, right?
Yeah.
So do you need an image or you don't need an image also?
It is possible for image. It is good, na?
Okay, so
Or
you
it is
required.
or it is the possible only call. It is also good because
Okay,
I am
I
getting the message.
haven't.
Some misuses
Okay,
happens. Lot.
okay, I haven't worked on that part. But if we can achieve till message and image, then we can also do this. Do the calling also. Or else we can do one thing. It will create a sound in your system. in your phone, key like object has detected.
Okay. Okay.
Or else calling could also be possible, but I haven't tried it out. My the well, while I was working on this, so my main agenda was I was looking for this image, how we can transfer that particular image to the Telegram. And I've also worked out with Facebook, WhatsApp also, ki since Telegram is not that widely used as WhatsApp, but there are few constraint which is there in WhatsApp, but it is possible to also deploy this on to get the notification on WhatsApp also.
Okay. Okay. Thank you,
Okay,
Animes.
thank you. Thank you, Parth. I think Divya, one more person is there who is raised, I guess.
Yeah, hello sir, this is Mahanta.
Okay.
So this application that you have designed is for desktop only, or can it work on mobile phones also?
You can deploy it on mobile phones also. So if it
So
is so
same, yeah,
okay, okay. Proceed.
right. So code needs to be changed, no sir, because for the mobile application things will
For the
change, like the
mobile
specification.
application, the code has to be changed widely. So I don't think much like uh, there will be a whole change on the system, because there you
Okay,
won't be creating anything on the web. So you will be creating on this what we say, Android app, right? Or else iOS app.
right.
So you need to deal
Mm-hmm.
with this Android system also, Android app development also. So
Okay,
it
okay.
can be
So
scaled down
the
to
application
Android.
is for desktop that you have designed.
Yeah, right now it's for desktop. It can also be scaled to the edge device also, a small edge device, which could be around 1000 or 2000. So when I say edge device, then Raspberry Pi or small Raspberry Pi also, on ESP32 cam, all those kind of devices.
Okay. All right, so thank you.
Yeah. For Android, I would say
About the
you
UPS.
need to yeah, create an application, but it can be scaled down to that.
Like then it will become a totally different application, no sir. Like
Yeah, it
the
would be
same
very
thing.
different.
Yeah, that's what.
Yeah.
Mhm.
But
Okay, thank you, sir.
I have a query
Mm.
of it. Ki if you have created it on your Android application, so how you will be using it and where you need the notification then?
No, sir. Let's say if some we have children at home, if they are
Okay.
using mobile phone, we want the notification that your children has unlocked the phone, because
Okay.
children they don't use desktop.
Okay.
Generally they use mobile phones. So the moment they unlock it, image got detected, and you get to see that okay, now your children or your somebody else has accessed the phone, and you,
Understood. Understood. So
that's
once your phone, like it can be said ki it is the connection between two Android phones. So once the person is detected in your mobile phone
uh,
camera, then
uh,
that notification has to be given up to your Android phone, right? Or
exactly,
your
exactly.
Telegram. Okay, okay, understood. It can be scaled to Android phones.
Right. You will be sharing these codes, sir.
Uh, yeah, if required, I can share.
Okay. All right. Thank you, sir.
Okay, thank you. Divya, I think Mahanta Chauhan has an query.
No, no, sir.
Sorry.
I just asked.
Okay, okay, you were the one. Okay. Anyone else?
Kindly please raise your hand so that I can unmute you if you have any queries. One second. Yeah, Path SI.
Okay.
So, Animes, it is possible on NVIDIA platform.
Yeah, it is.
Or which framework are you using? It is a TensorFlow. It is a
It's
PyTorch.
a TensorFlow. It's a TensorFlow framework.
Okay.
It can easily be scaled on NVIDIA platform. Directly you can take the code and you can deploy it there.
Yeah, but there is some dependence on NVIDIA board. That's why I'm asking.
Which
Because
that
the
has to be
other edge
looked at.
device is different and NVIDIA
Mhm.
platform is different. That's
Yes,
why.
yes, yes, yes. But it can be scaled to that.
Okay. Thank you, Animes.
Okay, thank you. Uh, Anyone?
Any more queries?
Are you interested to do other, want to see other projects, or you want to stop this?
Who wouldn't be
I,
interested?
if
Yeah,
anyone is
please.
interested on other projects, then I can. Otherwise, I can end.
Yeah, it is interesting if you have something
Yes,
different.
yes, if you can show another one.
Okay, fine. I'll show one more. Okay.
It is any live demo for this project, if we can see.
Live demo in the sense.
Means some misuse capture the image and we are getting the message from mobile phone like that.
Yeah, no, but right now it's in my system, so you need to use this code in your system, then you can do this live demo.
Okay.
So I'll try to share. Is my screen visible?
Yes, yes, Anish.
Okay, okay.
And participants, like if the chat is enabled with you, like please check with that LinkedIn account I've put. That's actually Animesh LinkedIn account, and you could find numerous so interesting projects. So maybe if you have that, you can please check it out. Or if you have the LinkedIn profile, please type it as Animesh Nayak, and you would get his profile.
Thank you, ma'am, for this.
Yeah.
Yeah, if you guys anybody have any queries or anything on this program, then just ping me there. I would definitely help you.
Yeah, you could literally see that from his comment section. Like when he releases a project, and there would be like numerous questions, and he has always answered every question so patiently. So I would definitely recommend you to please visit his profile. Animesh, if you don't mind, can we share your profile right now so
Yeah,
that
I'll
you
share.
can just scroll through all the projects there?
Okay, okay. And most of them are open source, so you can directly dive into it. Is my screen visible?
Yeah, perfect. Your LinkedIn
Yeah.
profile.
So this is it. So instead of demonstrating each and every projects, I'll directly show it here itself. If you have any queries, then so most of my post will be on the project only, so it will be there. So as you guys know, recently YOLO V6 has released. So I've tried it on the MacBook Mac machine. I have received it around 15 FPS. So it's quite promising, because when you work on this object detection model, mostly on CPU, you usually get not more than 4 or 5 FPS, or if it is Intel, if it is i9 processor, then also you cannot achieve more than 5 to 6 FPS on CPU. So with the CPU, I have received for 15 FPS here, and it was working good since it is very new model. I was tried inferencing it, and I have the repo in my GitHub. I'll give you my GitHub account, where I have almost most of the projects I have open sourced it. You guys can directly clone it, and if you have any queries, you can directly ping me on my LinkedIn. So what problems you guys are facing? So here is one more very interesting project. So it got good amount of likes. Just it's like under the CPU, I have received 674 FPS. So this is the technique which we have used while inferencing a YOLO V5 model, a basic YOLO V5 model, which in industry right now people are getting 20 or 15 FPS, even on CPU, not more than 20 FPS. I can bet on it, but I have tried inferencing it with the FPS of 75, fps, frame per second. So it will process 75 frames in single second. The technique here I have used is pruning technique. So if you have dived deep into this deep learning thing, so uh, when the deep learning is getting trained and when you get inferencing, so within this deep learning neural net, few nodes are those kind of nodes which are not being which are not contributing towards the detection, but they are just lying and making it computationally high. So what we have done here is we have cut down those nodes which are not contributing towards the detection of the model, making it complexity wise, make it reducing, so that we can inference it on CPU. So it was quite a great, I can say, a project which you guys should work on it. So deep sparse and neural magic are the platform where you can try and you can get the content on how you can inference it on fps with 75 fps or this kind of. In Intel i9 I got 75 fps. So I should look on. So this is my LinkedIn. If you have any queries, you can ping me there. Yeah. So let's just do the last demonstration for today. Any queries, anyone? So for this project, I'm also opening this environment. So I would highly suggest for each and every project, you should create one environment to track down this project, because this projects I have done 5 months, 6 months before. So tracking down this 5 months, 6 months project could be very difficult. So having an environment will be a boost to that.
Dolly, do you have anything to ask?
Yes.
Yeah.
Hi, Dolly.
Okay, so I want to ask you about like where you face the challenges while doing implementing the CV projects or in industry.
Like, uh, I didn't got you. What type of challenges you are talking about?
Yes, like while doing the CV projects or
Mm-hmm.
anything that implemented. So
Mm-hmm.
where you face the challenges.
The challenges I mostly face on this, and mostly on the technical part. So when I face, like, on it depends on the project wise. So if a particular project is on TensorFlow, so I need to dive into this TensorFlow format. So like it's depend on the platform. So TensorFlow or PyTorch. So it's highly on, like, project wise challenges are different. So when I feel these are the problems are this only. Key platform are the main challenges which I face. TensorFlow, if TensorFlow, then understanding because the structures of neural network changes from TensorFlow to PyTorch. The writing code get changes. Otherwise, the base fundamentals are same. So if you are good with the fundamentals, then you won't be facing much problems. But since if you are good with the platform under here, then you need to just brush up your this thing of platform. So there are documentations for it. One should look onto documentations, and to create different projects, I would suggest try doing small projects, uh, and then clubbing into 4 to 5 projects into one will create a huge project. You will get to learn more on that side. Is it okay, Dali, or you need?
Okay.
Okay. Thank you. So, yeah. So this is one of the project of worker safety. So here is the same GUI I have used, but here I have given a save video. So under the save video, it will be in this way. Otherwise, if I enable GPU, since GPU is not present, it will give me an error. If I enable webcam, then it will open up my webcam. Yeah, webcam. So since 2 3 processes are running parallelly, the FPS are bit low. Normally we get 2 to 3 FPS on CPU, but it's like if a person is detected in the frame, so we will get a timestamps of it of for what time that particular person is there in the that field of view, and there will be a given the person detected. It can be highly used on different platform, which I'll show, which I'll be later discussing on it. So this is the thing. So it's been 34 seconds I am present in the frame. If I leave the frame, the person detect will also go. It is 2 fps since it's not detecting, so the frames are high. So once person again come, then the timestamps will be the same thing, it is coming. So it can be used on restaurant, or it can be used on the areas where person has restricted, a person is restricted to go, but if person, if in another restriction area, if person is coming to that restricted area, then who was the person, for what time that person is coming under the frame, or yeah, that two log will be generated, and that two logs will be there present on this thing. So right now no person is being tracked, so zero tracking. So if a person comes under the frame, then here the tracking number will also see tracking one person is tracked for this much frame per second, and this is width is just the size of the frame. So if I enable this GPU, and if GPU is present in my system, then this FPS can move high to around, we can achieve till 25 or more than 25 FPS we can achieve. It's highly depend on what kind of GPU you're using, or computationally what kind of this thing we are using. So it is one of the small project, and here there is a drag where we can give the confidence to the this thing. If a person is present, so unless and until a model defines there is a 70% of confidence, it will detect, it won't detect. So if it is exceeding to the more than 70% of accuracy, then it will detect. So the main important of this project is like defining the timestamps of it, of the like for what, for how much time it is per person are present in the frame. So anybody is having any queries on it?
I think Parth Desai again has a question. Please
Okay.
unmute and ask Parth Desai.
Hello, Animesh.
Yeah, hi Parth.
I have one question. If
Hmm.
person stand exactly behind the one person, so it is possible to detect.
No, it's it's since it's computer vision, so it's depend on what a camera can see. If a person is present behind a person, and if his face or if some part is present, then it will detect.
How much person is visible?
We can say 30%. Like it's I'm just saying it with my experience. Like if a 30% person is detected, then it will detect. So if a person is detected in the frame, then it will detect. Like if a
Okay.
person is captured in the frame, then it will detect. So it's it again the same thing like how you have trained the model. If you have trained a model with a half face also as a person, that will detect that also.
So we have to make a data set regarding that.
Yes. It's not having its own intelligence. You are giving the intelligence to your system, so it's whole and soul depend on that.
How much data set needed if we are
How much?
creating a data set?
It's
The
how much data set?
means the images.
Yes,
Means
yes, yes.
how much images is needed.
For just for detecting a person, I would suggest if it is 1,000 or more than 1,000 will be okay. 1000 to 1200 also it will be okay to detect.
Okay.
Any other? Yeah, anyone?
Okay, so if anyone doesn't have any question, then Animesh, can I ask you something?
Yeah, yeah, sure.
This is what actually made me to give you a connection request. If you could see my screen, anyway, guys, this is like one of the very interesting projects that I found in Animesh
I was
profile.
about to showcase this, but I thought it could be very fancy, so I thought
No,
not
no, no, no,
to.
no, no.
Yeah, it has a
Anything on this?
story behind it. Yeah, yeah. I think one of the panel member who has come before, I don't know the exact person name, but he has also worked on the same thing, where a person and beside the person uh, there is a line will be coming. No, this Iron Man won't be coming. There's just a line will come. So I have used few models on it, and I have tried framing that.
It is a
So
air we are.
no, no, it has nothing to do with ARVR. It is core and soul, I can say, just image processing. And it just once a person is detected, there is a Google API of media pipe. So using media pipe, what we can do is like we can detect key points on the on the object present. So once you have got the key points, then what I did is like I have shifted the key points from my body to some pixel. So like let's just consider 1 meter. So I've shifted it first. So at that point of time, what output we will get is like we will get few key points. Then using key points, you can directly join the line. So you will get a line dancing with you. So with those key point you with this key point, what you can do is like at the keeping this 2 point under the reference, you can mask a different object or a different image. So I have masked body parts of the Iron Man and I have kept it.
Okay. Thank you. Thank you, Animus.
Thank you, Path. Anyone?
Anyone else? Maybe I'll unmute everyone so that they can ask queries.
Yeah.
Okay, so any questions?
No, from my side.
Yeah, okay, Parth.
I think no one. Yeah.
Okay, so I think we can take this as no questions. But
Yes,
then, as
yes.
I told you, it would really take a sufficient number, I mean, subtle amount of time to actually go through his profile. And then, as I told you, the session is recorded, so I'll be sharing the video with you. Along with that, I'll
Okay.
share Anmish's mail ID and LinkedIn profile. Please go through his profile and then see if there's something interesting that you want to collaborate with Animesh. Fine. So
Yeah,
thank you
sure. I
so
would
much,
love
Animesh.
to.
Yeah, definitely. And we are looking for I follow you very sincerely because you update so good. In fact, that YOLO
Okay.
V6. Yeah,
You will
I was
definitely
looking.
get something new then. Soon
Yeah,
you will get to.
definitely. Definitely. Like when there is a news that YOLO V6 is released, you could find a project in LinkedIn's, I mean, Anime's LinkedIn profile.
Yeah.
He's so super fast in that case. I think,
Actually,
yeah.
yeah, okay, okay. Actually, with YOLO V6, now YOLO V7 has also come within this yesterday or day before yesterday and working on it.
Oh, that's really an upgrade for a faculty itself, actually. And we can see a very good project on YOLO V7 in Animesh profile. And that kind of comparison when you do with YOLO V5 and V6, that's really so good. We
Yeah.
don't have to literally work on a project and see which one works better because we have all the results already in your profile. That's so good.
Thank you.
And Animesh, can you, if you have any GitHub account, can you please share that so that I can send it across to all participants?
Okay, okay. I'll share it that.
Yeah, fine. Okay then. Any questions? I think Abhimanyu, you raised your hand. Okay, I think that was by mistake.
Where can I share? Because the comment section is also
Yeah, no
not...
issues. You send it to me personally.
Okay.
I'll share it across to all the mail IDs.
Okay. I'll send it to you. Yeah.
Okay, fine. Thank you so much for a very wonderful session, and that was so interesting. And when we
Thank
got to
you.
see that all live demos and all, it was really so interesting. I truly hope that this would have been a motivating factor for many of the scholars and students here. Okay.
I think you can unmute everyone.
They are unmuted, and that's why we get to hear so many sounds.
Yeah.